Okay. Do you see it? Do you see the uh, XY coordinate system? Max? Yeah. Do you see it? Okay. All right. So this website is called desmos.com. Okay. So if you if you get in, here's what you're going to see. If you just first time get in, and and this is oh, and this is what you're going to see. Okay, that's the first thing you're going to see. And there are many things that they can be useful, and we're going to choose the graphing. So that's what we're going to use. And if you click that, we got to this XY coordinate system. Okay, so if we want to find something like a linear function, uh, find its xy intercept. So we got y, say, equal to 3x plus 2. Okay, so we type that. You see y is 3x plus 2. And you can see that we have this point. This is our x-intercept. And it's given us in this decimal form. So x is this x-intercept. You can write it as x-int, as x-intercept. That gives us this point, and that is 0.66 and repeating. So that actually is negative and 2/3. You get that. So the x-intercept, pretty easy to find. And another one is here, right here. That's the y-intercept. So therefore, we got 2 points. X-intercept is, you can write it as negative 0.6 bar and 0. So that's x-intercept. Then have y-intercept is 0, comma 2. Good? Okay, so I'll let you do some practice. Try different linear functions, and just type in the x-intercept and y-intercept. So let's say y is 2x minus 1, and see what you got. Okay, just type that in the chat.
Sorry, what are we trying to find?
Find the xy intercept. So graph it. Use the website. Okay, graph. Put this just like I did earlier, and find the x and y intercept. Good.
Sorry, it's just showing me like a diagonal line. Like it's not showing me an intersection point.
Well, if you type in what you see here, 2x minus 1, right? You
Yeah.
see that? And you see
Yeah,
here,
I did
it,
that, but it's not, it's just showing me like, oh, oh, never mind, it was zoomed all the way out.
yeah. So you have to go there and click it. Good. Okay. So you can see that the first one here is zero point 0.5 and 0. Okay. What that means? That means this is the x-intercept because it's the line and intercept this is the x-axis. So we call this x-intercept because that's the line intersect the x-axis. So that's the first point. Now this one is the y-intercept. The y-intercept is a line which intercepts the y-axis. So you can see that is point -1. Okay, so let's try uh, y equals to 3x plus 5, okay? Very good. Actually, you should get negative, not positive on first one. And you're going to use the parenthesis for this, okay? So 3x plus 5, you can see that this point actually is negative. So the way you're going to type, you're going to type negative 1.6. You can use a bar here. So because just repeating and 0. And the next one will be uh, 0 or cos 5. And if you're going to zoom out a little bit, you can see that the point is 0 and comma 5. And that's why we call this function as a slope-intercept function, because this number is the y-intercept. Okay, let's try uh, y equals negative 3x plus 6. Okay, see this one, okay? What we got here is y equals negative 3x plus 6. And now you can see this point.
So each
Hello?
generation assigned to a decade and they're split into
I
part
hear
one.
something.
First, we have the 80s babies, part one, who are basically just Gen Xers.
Is that
And then
you
we have
playing something?
vague memories of a time before the internet.
Hello?
There
I
are
hear the audio.
Oh, sorry. Could you turn?
Okay.
Sorry, is somebody else?
All right. So this actually is 2 comma 0, not negative 2. Good. So you need to put negative 3 in front. Okay. If you put positive 3, that's what you'll get. That's
Sorry, I
what you
accidentally
got.
put positive.
Yeah, that's fine. Okay, let's try just a couple more. Okay. Then we're going to try the quadratic functions. That's more interesting. Y equal to say 5x plus 7. Very good. Okay, good job. So now we're going to do quadratic functions. So we can see that linear function just a line. Quadratic function is we call that it's a parabola. It's either like this or like this. Okay. So let's see. We do very simple one: x squared plus 3x plus 2. So now we can see uh, what it looks like. So y equals x squared plus 3x plus 2. Okay, now you can see, zoom up a little bit, and here is the vertex point. You can say it's minus 1.5, comma, negative 0.25. And then we have 2x, this called zeros, which basically is another way of saying the x-intercept. And there is one here, and there is one here. And then, of course, we have the y-intercept. So now we have to give 1, 2, 3, 4 points. The first one is the vertex point, negative 1.5 and negative 2.5. And the second one is second two are the zeros. So negative 2, 0 is first one, and the negative 1, 0. And lastly is the y-intercept. Good. So I just give that in this order. So the vertex point, the y-intercept points is also called zeros, and then we got the y-intercept is that. Okay. So let's try y equal to x squared plus 2x minus 3. Okay.
How do I write squared?
You use the tilde symbol like in your
Oh, the caret.
yeah, the caret.
Sorry, I wasn't finished. I mean to hit the enter button.
Okay. So we do the first one is the vertex point, and then after that will be the x-intercept points. The last one will be y-intercept point. Okay. So you should
So what's
have
the order?
the fourth one is a y-intercept point. So you can see that plus 2x minus 3 and see where we have. Okay, this is our vertex point. So we do that first. Then after that, we got negative 3, 0, and also 1, 0. Good. And that's our y, x-intercept. Lastly is this one, 0, negative 3.
Okay,
Good.
thank you. Mhm.
Yeah, it's kind of like different from the order you got down here, but we just
Mhm.
want to make sure that we are good with the names of those points. Okay, let's try a different y equals x squared minus 3x and minus 10. Okay. All right. Very good. So got negative 3x minus 10. Okay. We can see that that is our, so it's actually 1.5 negative 12.25. Okay. And then we got this point, negative 2, 0. And there's 5, 0. Then, of course, this is our y-intercept. Very good. Very good. Okay. So we'll get y equal to negative x squared plus 3x and the plus 4. Okay. That's all right. All right. So let's work on this. Okay. Yeah.
Sorry,
So we
what are we
got
doing?
here, got
Oh,
new here. Good. we got negative x squared plus 3x plus 4. And we see that's the point here. Okay, 1.5, very good. And this 2, negative 1, 0, and 4, 0. And this is our y-intercept. Very good. Okay, so now we actually can use this to looking at how the function works. So far the function we learned is the linear equations. The standard form we write as mx plus b, and we have also the quadratic equations is ax squared plus bx plus c. Okay, and now we can see that something about the quadratic equations. Or let's look at the linear equations. Something very the property of that is, first one, we see that this b here, this form is called slope-intercept form. And the reason for that is this is our slope, and this is our intercept. So we just slope-intercept form. So let's look at a couple of those, and we can see how that works. So if I do this, 3x plus 1, and you can see that the y-intercept is 0.0, 1, which makes sense, because if it's y equals 3x plus 1, now if x is 0, then y has to be 1. So that's why this has to be the y-intercept, and that's why this is our the y-intercept here. And the 3 here is the slope. And you can see here, why is that? If you pick any points, let's say if we pick this point here, and if we move to here, and that point will be here. Now, this point here is 0, 1, and the other point here is 2, this comma, it'll be 7 here. So therefore, if you're looking at this side over that side, and this is 7 minus 1 is 6, and 0 to 2 is 2. So 6 over 2 is 3. So that's exactly just what we have. We got here. This one, this is our slope. Okay, so that's why we call it a slope-intercept form. And of course, we could, in terms of the slope could be positive, could be negative. Now, this is a positive slope. That means it's going up. But we could have negative slope. Like, for example, we're going to have function y equals negative 2x plus, say, minus 2. Now you can see that the negative slope is going down. If you think about, we go from the negative from left to right, then this is going down, the negative slope. And also, of course, we have y-intercept, which is negative 2 right here, a negative 2. Okay, that's pretty much what we about the linear functions. Now, quadratic functions, we know that it has to be either this way or this way. Now, what determines going up or going down? And that has to do with this a, the first coefficient. Okay, so this a, if this a is positive, then we're going to have we call it concave up, pointing up, or open up. So the right word to call that is called concave up. And this is called concave down. Okay. So we can see some examples. For example, y minus 2x squared plus 3x plus 1. I can see it's going up. But if we're going to have a negative on the first one, so negative 3x squared and minus 4x and minus 2, and you can see that it's pointing down. So up and down has to do with the polarity of the first coefficient. Okay, and this coefficient c is like on the linear, when we had the linear function which we call b, and that is the same as this is the y-intercept, and this is also the y-intercept on the c. You can see on the first one, the c is 1, so the y-intercept is exactly here, which is 0, 1. And on the second one, the c is negative 2, and if you look at the y-intercept, it is 0, negative 2. Good. And there are some other properties besides concave up and concave down, is that the quadratic equations is always it has similarities. And well, first of all, they all have the vertex point, either vertex point on the bottom or vertex point on the top. And depends on the function. Some function will have x-intercept, some function doesn't have that. So in this case, the first one, the red one, has a y-intercept, x-intercept. There's 2 points. Is here and here. But not the blue one. The blue one has no x-intercept, but they all have y-intercept. You can see that. They all have y-intercept. And they all have the vertex point. But the green ones, the blue ones has no x-intercept. Now, the line of symmetry is always go through in this case, go through the vertex point. And this one is here. And it's just like symmetrical to, so the left and the right, they are symmetrical. So it's kind of like if you just did half on this side, you can just copy that over, you get exactly that side. Or you can imagine you fold it along the called axis of symmetry. If you fold it that way, they'll match. Okay, and there is something interesting about, there's a relationship. If we have x-intercept point, there is a relationship that is the vertex point, this point, is always between the y-axis coordinate, or the vertex point here, is always between the two x-intercept point. And you can see that this is the point, negative 0.75. And so in the middle, right in the middle, which is the average of these 2 points. So it's negative 1 plus negative 0.5 divided by 2, which gives us negative 1.5 divided by 2. That will be exactly 0.75. So that's one of the properties of doing this. Okay, now we're going to expand that into other functions. The other functions, we call them polynomial functions, because the linear function plus quadratic function, they are part of functions called polynomial functions. So polynomial functions, it means that poly just means many, nomial just terms. So there's two terms, there's three terms. But we could have function like y equals, say, x to the third plus 2x squared plus, well, this minus 3x and plus, say, 4. Now, in this case, this part is the quadratic function, but here we have one more term, which is the cube. So this is called cubic function. And if we graph that, we'll see what's it look like. Y equals x cubed and plus 2x squared and minus 3x plus 4. Good. Well, where'd that go? But we'll find it. It's here. It's kind of interesting graph. There is two terms. In the quadratic functions, we only have just one term, but this we got two terms. You can see here, this it go one turn, there's another turn. So like you're going up and you're going down, that's one turn. Then going down and going up is two turns. And okay, so this is called a cubic function. And the cubic function is always have a y-x-intercept point. This one here, right here. Sometimes there are more, but this one is just here. Okay, we can also look at called quadratic, which is have we got the fourth power on the x. Let's say x to the fourth plus 3x to the third minus 2x squared plus x minus 3. Okay, so let's see what that looks like. And let's put those two together. We can actually compare. So y equals x to the fourth and plus 3x to the third and minus 2x squared and minus 3. Okay, let's see. Now we can see this function, we have the one, there is a vertex point here, and we got one turn here, and here we almost made a longer turn. And down here, it looks like we're going to have another turn. So we can look at different kind. The type of it, that's a negative x to the fourth, plus 2x to the second. That's kind of interesting graph. And minus 4x. And let's change that to a little bit. That. Okay. And minus 4. Okay, we can see that there's another, this kind of graph. So they got one turn, two turn, and three turn. And so in terms of number of turns, it won't be, it always the leading, this one is called the degree of the quadratic function, the polynomial function. This we call that fourth degree. And there are at most 3 turns. And so you can see that when we have y equals x to the third plus 2x squared minus 3x plus 4, our degree is 3, and we have at most 2 terms. Won't be more than that. And sometimes we only just have 1 term. But at most is 2 terms. Okay, I'm going to show you one more. Now we're going to looking at degree of 5. Degree of 5. Let's see. Y equals x to the 5th plus 3x to the 4th minus 2x to the 3rd and minus, say, 5x and plus 1. Well, let's see how that looks like. X to the 5th plus 3x to the 4th and minus 2x to the 3rd, then minus 5x and plus 1. Okay, let's get rid of all that. Now you can see we got another. Well, this one we can see we got only have 2 terms. One is on the top here, and another one is here. Okay, so we can just do kind of a recap on what we just learned. And we are learning something called, first we learned how to use with Desmos, how to use that help us to visualize the functions. And we also, we learned about, we call that polynomial functions. And simple one is a linear. Linear is y equals mx plus b, and then we have quadratic. Then y is ax squared plus bx plus c. Then we have cubic, and that's y equals ax to the 3rd and plus bx squared plus cx and plus d. Then we call 4th degree. That means the first one is x to the 4th. This is a x to the 4th plus b x to the 3rd plus c x squared plus dx plus e. Then finally we get on 5th degrees. Of course, we can keep going, but here we just need to just look at only the first 5. It's y equals to a x to the 5th plus b x to the 4th plus c x to the 3rd and dx squared and plus e x and plus a b c d e f. Now, if we keep going, then we run out of the alphabet. So we have another way of writing it is like if with nth degree. Now, in mathematics, we're going to write as this. Instead of A, B, C, D, we just say the first one is A, N. This is the x to the n. Then second one, A, N minus 1. This is x, N minus 1. And then eventually we got a second square and A1, x, and then A0. Okay, so that is the general way of writing it. That covers any n. But normally, just for the first 5, we're just using the alphabet. But once we got to more general, we'll get this. But one thing about the polynomial functions, the last constant is our y intercept, and also we could have in terms of the x-intercept, we can see that if you have the first one, the linear function, we only have 1. So we're going to write down here this and the degree. and this is the number of x-interceptions. So if n is 1, then we have 1. Now, if n is 2, we actually have 3 choices. We could have 0, no, x-intercept, or 1, or 2. Now, if we have 3, then we could have either 1, always have 1, or 2, or 3. Now, if we have 4, then we could have 0, 1, 2, 3, 4. And if you got 5, if it's odd, we always have 1. 1, then 2, and 3, and 4, and 5. So it's the number of x-intercepts. Good. And also number of turns. Number of turns. Now, in this case, if it's linear, we don't have turns. If it's quadratic, we got 1 turn. If you got cubic, we have we only have less than equal to 2 turns. Okay, could have 1 turn or 2 turn. When you got 4, we also can be less than equal to 3. We got 5 and less than equal to 4. So it's in terms of number of turns and number of x-intercept. Okay, now I'm going to give you a function, and you tell me by graphing it, you tell me the number of x-intercept. You don't have to tell me where they are, just tell me the number. X-intercept and also number of turns. And before that, so this is B and C, but A is number of degrees, okay? Good? If I give you a function, you'd have to tell me number of degrees, number of x-intercept, and number of turns by put on in using decimals and to show me. So y equals to x third plus 3x squared minus 4x and plus 2, okay? Good? Yeah, are we good, Grayson? Okay, yeah, you just use decimals to graph it, and you see what kind you got. Grayson, need help? Well, just graph it and you see, okay? You type in y equal to x to the third plus 3x squared minus 4x plus 2. Good. Now you can see it had two terms, but first of all, number of degrees. Number of degrees 3 because this is to the power of 3. But the terms we got 2. And actually that's on C. B is number of x-intercept. We only have 1. This is here. And the number of terms we got 2. One is this term. One is this term, and one is this term. Good. Okay, I'll give you just one more. Okay. You plug in here. This time is y equals x to the fourth minus 3x to the third plus 4x squared minus 2x and plus 1. Okay? Yeah. So tell me number of degrees, the number of x-intercept, and number of turns. Okay? So you just need to plug in, type that into the decimals. Okay? Person?
1 sec, sorry. You're just turning the same answers as last time, the
Yeah.
the
So,
degree.
right. A is number of degrees, B is number of x-intercept, and C is number of turns.
How can I see the degree?
Degree is just basically looking at this one, the first term. So
Oh,
the degree, number of degrees is 4.
okay.
And do you see any x-intercept?
Is it at 1?
No, there's no x-intercept.
Oh, yeah, never mind. Sorry, I was thinking of y-intercept.
Yeah, there's y-intercept and no x. Okay, number of turns.
Just 1.
Yeah, very good. Okay, that's all we have. Okay,
Thank you.
bye.